dinosaurs actually have sex? It's one of those questions that sounds like a joke at first, and then turns out to be a genuinely difficult scientific problem. Dinosaurs left behind bones, footprints, eggs, even skin impressions in exceptional cases. What they didn't leave behind is soft tissue, observable behavior, or anything resembling a diagram. So piecing together how a 5-ton animal covered in spikes, plates, or dragging around a 9-foot tail actually managed to reproduce has taken paleontologists a surprising amount of careful, indirect detective work, built almost entirely from comparison, physics, and the occasional very lucky fossil. Here's what the evidence actually points to. The starting point is anatomy, specifically a structure most people don't think about at all: the cloaca. In reptiles and birds, the two groups most closely related to dinosaurs, and the two groups scientists lean on most heavily for comparison. Reproduction, waste, and egg-laying all happen through a single multi-purpose opening near the base of the tail, rather than through separate systems the way mammals have. Since dinosaurs sit squarely between reptiles and birds on the evolutionary tree, and both of their closest living relatives use this same basic setup, it's about as safe an assumption as paleontology gets that dinosaurs use the same system. That detail alone answers the most basic mechanical question. But it opens up a much harder one. Given the sheer size and shape of a lot of these animals, how did that actually work in practice, without someone getting seriously hurt in the process? For a long time, this is where things got genuinely puzzling, mostly because so many dinosaurs seem almost deliberately built to make mating difficult. Stegosaurus had rows of large bony plates running down its spine and dangerous spikes at the end of its tail. Ankylosaurs were covered head to tail in heavy armor, bony knobs, and in some species, a massive club-like structure at the end of the tail capable of breaking bone. Even something as basic as a long, heavy, muscular tail, which the vast majority of dinosaurs had, armored or not, raises an obvious logistical problem. Two animals built like that can't exactly line up the way most mammals do, and getting it wrong could mean a serious injury from a spike, a plate, or several tons of misplaced weight. The leading explanation borrows directly from modern reptiles, particularly crocodilians, which face a fairly similar problem with their own long, thick tails and armored backs. Rather than a face-to-face or fully aligned position, mating likely involved one animal approaching from behind and to the side, with tails angled out to one side rather than trapped underneath the body. This lateral approach shows up repeatedly across reptiles today, from crocodiles to large lizards, and it solves the tail problem fairly elegantly. Instead of two long, rigid, or armored tails needing to somehow overlap directly, they simply angle away from each other. Some researchers have also proposed that certain armored or spiked species may have needed a real degree of cooperation and positioning that more lightly built dinosaurs didn't require. This isn't just speculation for its own sake, it's grounded in a very real mechanical problem. A 2011 study specifically looking at Stegosaurus, sometimes referred to informally as the Dinosaur Kama Sutra paper in the press at the time, walked through exactly this issue, concluding that the plates and tail spikes likely required a fairly specific approach angle, and a cooperative partner willing to shift her tail out of the way to allow contact at all. It's not a glamorous picture, but it's a mechanically plausible one, and it fits with what's observed in living animals carrying similarly awkward body plans today. Sauropods, the giant long-necked dinosaurs like Brachiosaurus and Diplodocus, present their own version of this problem, just at a completely different scale. These were, by a wide margin, the largest land animals to ever exist, and their sheer size means the logistics of mating weren't really about spikes or armor at all, but about basic physics. Some researchers have suggested that males may have had to rear up, at least partially, using their tails for support, essentially forming a tripod with the hind legs and tail to take on the weight involved. Given how thick and muscular sauropod tails were, this kind of tripod stance isn't as far-fetched as it sounds. The same basic posture has been proposed for other sauropod behaviors, like reaching even higher into the treetops than usual. Then there's the question of how any of this even got started, how a multi-ton animal signaled interest in the first place, long before actual physical contact was even on the table. This is arguably where the fossil record has produced its richest and most convincing evidence. A huge number of dinosaur features don't seem to serve any obvious survival purpose at all, but make a lot of sense once you consider them as display structures instead. The elaborate hollow head crests on duck-billed dinosaurs like Parasaurolophus are a strong example. CT scans of these crests have revealed complex internal air passages, essentially built like a natural wind instrument, likely used to produce distinct, resonant, low-frequency calls. Different crest shapes across related species would have produced noticeably different sounds, potentially allowing individuals to advertise their size, health, species identity or availability to potential mates from a significant distance, long before they were ever close enough to be seen clearly. The dramatic plates running down Stegosaurus's back may have served a similar visual role, especially if they were richly supplied with blood vessels, as the bone structure suggests. That would have allowed the plates to potentially flush with color, or radiate heat in a visible way, not unlike the way some modern reptiles use color changes and body language during courtship displays today. Feathered dinosaurs add an entirely different layer of evidence to this picture. Exceptionally preserved fossils, particularly from certain sites in China, have captured feather impressions in enough detail to actually reconstruct original color patterns using fossilized pigment structures called melanosomes. Some of these reconstructions have revealed elaborate patterns, iridescent structures, and color combinations that look a lot more like the ornamental plumage of a peacock or a bird of paradise than anything that would be useful for flight or basic insulation. That strongly suggests these features existed specifically to be displayed and noticed. The exact same evolutionary logic that produced a peacock's tail today, there's also direct physical evidence of actual courtship behavior, not just physical appearance. A set of large, deliberately scraped out depressions found in Cretaceous rock in Colorado, dated to roughly 100 million years ago, has been interpreted by some researchers as fossilized dinosaur scrape ceremonies. This is a specific, recognizable behavior still seen today in ground nesting birds like plovers, where males dig and kick up dirt in a rhythmic, showy display, essentially demonstrating fitness and nest-building ability to a watching female. If that interpretation holds up under further study, it means at least some dinosaurs weren't relying purely on looks or sound. They were performing, quite literally putting on a show, the same way a lot of modern ground nesting birds still do in open fields today. One more piece of this puzzle involves figuring out which dinosaurs were male and which were female in the first place, and that's turned out to be surprisingly, frustratingly difficult. Unlike a lot of modern animals, dinosaurs generally don't show dramatic, easily identifiable differences between sexes in their skeletons the way, say, a peacock and a peahen do. A few possible cases of sexual dimorphism have been proposed over the years, including slight differences in crest size in certain duck-billed dinosaurs, or subtle variations in hip bone structure that might relate to egg-laying capacity. But very few of these proposed differences have held up well once larger sample sizes were examined. In several well-studied instances, what once looked like a clear male versus female difference turned out to just be individual variation, or simply animals of different ages caught at different growth stages. There has been one genuinely reliable breakthrough on this front though, and it doesn't come from bone shape or size comparisons at all. It comes from a specific type of internal tissue called medullary bone, a temporary calcium-rich layer that forms inside the leg bones of female birds specifically while their bodies are actively producing eggshells, then gets reabsorbed afterward. This exact tissue type has been identified inside fossilized dinosaur leg bones on multiple occasions, including notably inside a specimen of Tyrannosaurus rex. Because medullary bone only forms under this one specific reproductive condition, its presence gives paleontologists a rare, direct, biologically unambiguous way to confirm that a particular fossilized individual was not just female, but actively producing eggs at the exact time it died. It's one of the only cases in dinosaur paleontology where soft, temporary biological evidence, rather than just skeletal shape, settles the question of sex directly and with real confidence. It's worth pointing out that not every proposed explanation in this area has held up well over time, and that's a useful reminder of how much of this field is still genuinely being worked out. Early illustrations from decades ago sometimes lean towards simplistic, almost cartoonish depictions of dinosaur mating, largely guessed at with little real evidence behind them. Modern paleontology has moved toward a much more careful, comparison-based approach instead, treating dinosaurs less like mysterious monsters and more like a specific branch of the same reptile and bird family tree that includes crocodiles, lizards, and every bird alive today. That shift in approach is a big part of why the picture has improved so much. Instead of guessing at what looks dramatic, researchers are increasingly asking a simpler question. What would actually work, mechanically, for an animal built exactly like this one, based on what its closest living relatives already do? Once mating actually happens successfully, the process didn't end there, and it's worth briefly touching on what came next, since it rounds out the full picture. Dinosaur eggs, based on both fossilized shell fragments and remarkably preserved nesting sites, varied enormously in size and shape depending on the species, from small, elongated eggs laid by smaller theropods to eggs over a foot long from some of the larger species. Nesting sites discovered in places like Montana and Mongolia have shown eggs arranged in careful, deliberate patterns, sometimes in large communal colonies with dozens of nests packed close together, suggesting at least some species return to the same nesting grounds repeatedly, generation after generation, not unlike sea turtles or colonial seabirds today. Some fossil finds have gone even further, capturing adult dinosaurs apparently brooding directly on top of their nests in a bird-like posture, wings or arms spread protectively over the eggs. This kind of direct evidence for parental investment, showing up so clearly in the fossil record, reinforces just how bird-like dinosaur reproduction really was across the board, from the moment of mating all the way through to raising the next generation. So, pulling this all together, dinosaurs almost certainly reproduced the way their closest living relatives, reptiles and birds, still do today, through a shared cloacal opening, with mounting positions adapted around body shapes that ranged from manageable to genuinely awkward depending on the species, likely borrowing the same lateral from behind approach still used by crocodilians. Elaborate crests, blood-rich plates, vivid feather colors, and even scraped-out courtship grounds suggest a lot of dinosaurs invested heavily in display and performance long before mating ever happened, not unlike a huge number of birds today. Figuring out male from female remains genuinely difficult in most cases, but discoveries like medullary bone have given scientists at least a handful of confirmed direct answers, T-Rex among them. And once mating succeeded, the fossil record shows careful nest building, communal nesting grounds, and even direct evidence of parental brooding, closing the loop on a surprisingly bird-like reproductive story from start to finish. None of it was ever going to be simple for animals this size, this armored, or this strange. But between fossilized behavior, preserved soft tissue, ancient nesting grounds, and careful comparisons to living relatives, the picture has gotten a lot clearer, and a lot stranger than it was even 20 years ago. If this was interesting, hit like and subscribe for more deep dives into dinosaur biology. And drop a comment, what dinosaur mystery should we dig into next? Thanks so much for watching, and see you in the next one.